Hello people, in this video I would be showing you how to find the state model expression for the circuit given below. This has got two inputs E1 and E2, and to watch the previous video had a problem which had a single input, but in this case we have got two inputs. Now let us see how to solve it. In this, let us again start by drawing a model. So this represents the system. System has got Vc as the output, which is V0. I can equate it to Y. Now here I observe that there are three state variables. The reason is the current through the inductor L1, current through the inductor L2, and also the voltage across the capacitor C will be the state variables. So I have to take x1, x2 and x3 as the state variables, that is IL1, IL2 and Vc. The input will be 2, that is E1 and E2, which I take as U1 and U2. So this is how the model is drawn. Once the model is drawn, now you can proceed by writing the expression standard formats, that is output equation can be written as y is equal to a into x1, x2 and x3 plus b into the input, and the x dot, that is the standard format of the state model equation, can be written as c into x1, x2, x3, which are the state variables, plus d into the input. Now let us start by writing the output equation. We observe that output equation is having only one state variable, that is Vc. Hence I can write it as y is equal to, it does not have x1, that is IL1 is not present, IL2 is also not present, so x2 is also not present, so therefore I put zeros, but Vc is present in the output, so therefore I represent it as 1 over here, so that when I perform the matrix multiplication I would be getting the required answer plus 0 into u. This represents the output equation. Now let us see how the state model equation is written. State model equation. To write the state model equation, let us first write the state models, that is x1 dot is equal to dIL1 by dt, x2 dot is dIL2 by dt, x3 dot is dVc by dt. Now I have to obtain the expressions for these. Let us start by applying KVL to loop 1. If you apply KVL to the loop 1, then you get U1 is equal to IL1 R1 plus L1 dIL1 by dt plus voltage across the capacitor I represented by Vc. Now U1, let it be as it is, IL1 is equal to x1, so therefore I represent it as x1 and take it on the LHS. And Vc as well, which represents x3, I take it on the LHS whole divided by the L1, I take it to the denominator. dIL1 by dt represents the x1 dot. So this represents one model. So I can obtain the first row by using this particular expression. Let us find for x2 dot and x3 dot similarly. Now applying KVL to the loop 2, I have got E2 is equal to R2 IL2 plus L2 dIL2 divided by dt plus Vc. Now again I take all the terms excluding this term to the LHS and then I simplify. E2 is nothing but U2. This should be equal to R2 IL2 is x2 plus L2 into dIL2 by dt is x2 dot plus x3. Once I take it to the LHS, it becomes U2 minus R2 x2 minus x3 whole divided by L2 should be equated to x2 dot. Once I am done with this, I have obtained an expression for x2 dot. Now let us obtain an expression for dVc by dt, that is x3 dot. Now to obtain the expression for x3 dot, I know that the current through the capacitor is given by C into dVc by dt, which is equal to IC. From the expression, it is clear that dVc by dt into C is equal to IL1 plus IL2, because that is the current flowing through the capacitor. IL1 and IL2 represents the two state variables, so I represent them as x1 plus x2 divided by, I take C to the denominator, which is equated to x3 dot. So using this equation and the equation for x1 dot, I would be writing the state model expression now. So the state model expression has got the standard format, that is x1 dot, x2 dot and x3 dot, okay, which is equated to a 3x3 matrix. Why 3x3? Because there are three state variables, x1, x2 and x3, plus the input u of t multiplied by a matrix. Now x1 dot expression has got the inputs, this is u1 and u2, because there are two inputs. Now this is how the state model equation looks. State variables multiplied by matrix, inputs multiplied by a matrix. Now from the expressions we have obtained so far, we know that x1 dot has got the expression 1 by L1 into U1. Therefore I write 1 by L1 over here, and it has got x1 with a coefficient minus R1 by L. So I write minus R1 by L over here, L1. Then it has got x3 with a coefficient minus 1 by L. So I write minus 1 by L1 over here. Since it does not have the x2 component, I replace it by 0. Now similarly I write for x2 dot, wherein it has got here, since in the x1 dot expression I have obtained, it has absence of u2, so therefore I write 0 here and 1 by L1, because u1 has the coefficient 1 by L1 in the expression obtained. Now for x2, for x2 dot in the expression obtained over here, 1 by L2 is the coefficient of L2, U2. So therefore, I write 1 by L2 over here, and x2 has the coefficient minus R2 by L2. So therefore, x2 dot has got x2 coefficient as, since there is no x1 coefficient, I write 0 over here. Then here it is minus R2 divided by L2, and then the third term is minus 1 by L2 because x3 has got the coefficient minus 1 by L2. Okay. Now x3 dot has got this expression, which is 1 by C over here and 1 by CO in the second term, whereas in the third column it is 0 because there is no x3 term over here, and the x3 dot does not include any of the input, so therefore I can write 0 over here and 0 here as well. Now this represents the state model equation for the electrical circuit given below.